Hello everyone and welcome to Van Tech Corner. In the previous videos, we unboxed the FastRhino R68s and set up a working internet connection. In this video, let's take a closer look at the device and check out the R68s specification as well as the internal components. First, let's go to the main point. The FastRhino R68s is purely a router. It doesn't have an HDMI port for video output, nor the M2 slot for NVMe or SSD, right? However, it is budget friendly and selling price can be considered lowest in the market. The R68s with 2GB of RAM is selling at $70 and the 4GB RAM versions is available at $80. Please note that this is the pricing for China domestic only. If you're going to purchase from AliExpress, the price is higher. The R68s has a very simple casing design. It is a plastic case with a lot of space on top, bottoms, and rear sides. This is good for air ventilation purposes, especially when adding a cooling fan on top of it. However, this will also bring in more dust to the PCB inside. At the back, we have 4 network ports, 2 1 Gigabit Ethernert ports and 2 2.5 Gigabit Ethernert ports. Next to it is a 12V DC power connector. At the front side, we have 2 USB 3.0 ports. The ports on the right side are USB OTG and it can be used for firmware installations and debrick. Next to it, there are 2 LED indicators. The power LED is green and the activity LED is blue. If you don't like blinking LEDs, you can turn it off on OpenWRT. Lastly, we have 2 buttons. One is the recovery buttons or the match buttons. This will turn the device into match mode and you can install the firmware with Rockchip developer tool. The other one is a reset button and it will just simply restart your router. Now let's open the case to see the internal components. In the center of the board is the Rockchip RK3568B2 SoC. It is a quad-core A53 CPU and the clock can go up to 2 GHz. Beside the built-in NPU, this SoC also supports AES encryption. It is attached to the 25mm by 25mm heatsink. Next to it is the 4GB LPDDR4 chip from Ryzen and the 16GB eMMC 5.1 chip from Frosty. On the right side of the SoC, you will see a small IC with heatsink. This is the PI6C557-05BLE, a spectrum clock generator used to reduce the electromagnetic interference. On the rear side, there is the RK809 power management IC, also from Rockchip. We can see that the DC power inputs go to the JK200L resettable fuse and a series of solid capacitors, inductors, and resistors before it is supplied to the RK809s and other components. On top of the PCB, there are the unpopulated UART debug pins next to the USB port. This will be useful if you want to see what is going on in the console or configure the routers when using access via LEDE. Please note that this is 3.3V and you need to check the voltage of your serial TTL adapter before connecting to it. Similar to the Nanofiles R5s, we have the Rockchip RTL-A211F Ethernet transceiver for the 2 Gigabit Ethernet ports and the Rockchip RTL-A125GB Ethernet controller for the 2 2.5 Gigabit Ethernet port. Something you will also notice is the 4H5007NL pulse transformer connected to each Ethernet port. Taking a look at the back of the PCB, you will see that the soldering problem for the USB 3.0 ports parts which were visible on the product sample page had been fixed. Well done to FastRhino team. The R68s is also open source in hardware. You can download the full schematics of the device and do further research if you need. The link can be found in the video description. The R68s come with a 12V 1.5A power adapter. According to the manufacturer, the power consumption in idle state is 4W, and during full load, it can go up to 9W. The FastRhino R68s is pre-installed with LEDE R22.6.11 with kernel version 4.19.245. This is a fork of LEDE or OpenWRT that were mainly developed by LIN and other contributors. It is widely used by the China communities and offers better performance on some devices due to the private package and firmware from LIN. Beside the core LEDE package, you will also have other pre-installed packages such as CPU frequency, block mount, dynamic DNS, way on LAN, shadow shock, zero-type, VPN, and etc. This will be useful for beginners but somehow messy for advanced users. The R68s firmware released by LIN support two types of installation. Firmware name with eMMC is for mushroom mode installation with the arcade depth tool. Firmware name with system upgrade is for LEDE OpenWRT web UI upgrade. You can also download the firmware that got pre-installed with Docker as well. Due to the video length, I will not go too deep into this topic. We will have a separate video for that in the future. Beside the builds from LIN, you can find the R68s firmware from iStore. It only comes in .img format and you will need to install it via mushroom mode. Right now, OpenWRT support for RK3568B2 is still in initial state, and LIN or iStore guys rarely push their device into OpenWRT master. I don't expect that the device will be officially supported soon anytime, but let's hope for that in the near future. Right now, the FastRhino R68s is running OpenWRT R22.6.11 and it is quite out of date. So let's grab the latest release from LIN and give a try. And for these installations, I'm going to try out the build with Docker. I don't want to mess up with the USB cable because I don't have a USB Type A to Type A anyway, so I'm going to use the system upgrade image. Let's get this one, which is the latest release. So if you don't want to have OpenWRT pre-installed with Docker, you can try this one with just a pure router. The firmware has been successfully downloaded, and let's give it a try. Let's go to System, and then let me find Backup and Flash Firmware. I don't need to keep the setting, so I just untick this one and select our firmware. Alright, hit Open, and let's go. This upload image doesn't contain a support format. Make sure that you choose the generate image format for your platform. Alright, so unfortunately the file is .rar format, okay, as you can see right here. So we will need to extract it first. Okay, very good. Let's give it another try. Untick this one, browse, and then select this one, open, and let's go. Perfect, all is good. Let's proceed. Now I can open the command prompt and try to ping the router. So ping 192.168.100.1. Request timeout, and the router should be restarting or handling the system upgrade. The router is off, and let's wait if the page is automatically refreshed. It looks like we need to refresh the page manually. And the rules, and let's see what is the password. This should be password. Very good. Dump save. So we have OpenWRT R22.7.23. LuCI master. The kernel version is 4.19.245 as usual. But unfortunately, the language is Chinese again, because this is a build for China, so I have nothing to say on this. Let's go to system and let's change the language to English. Save and apply. Alright, so after I change the language to R2, it is still Chinese. Alright, so after the second time, you change to English. Good. Alright, so what do we have on the system? Yes, very usual ones and a lot of pre-installed package and applications. And on Docker, let's see what do we have. We have the overview, the Docker versions, the CPUs, and the total memory. And right here we can see the container as well as the image that we have. Very good. Let's see. Image. Networks. So right here we already have 3 network. None host bridge. Okay. Let's see what else. Volumes. There are no volumes, events, and configuration. We do have NAS, KOD Explorer, Qubit Torrent, USB print server, HDD idols, FPT servers, and a lot of things. We can see that the menu bar is full of columns. Alright, so that is good. So now let me give it a try if the internet connection is still working fine. Oh, by the way, we can see that the CPU temperatures is now 50 degrees Celsius. And if you take a look, you can see that we have 1, 2, and 3, and 4 network ports. And the Ethernet zeros, I don't know why it is showing 10 megabit per second, but actually right now, only this port is the one port connected, and it is 1 gigabit, correct? This Ethernet 2 is currently connected to my PC and is having 2.5 gigabit per second, which is correct. This one, I assume it is another 2.5, but why we have the 10 megabit per second port? I think something is wrong with this monitoring or listing right here. Let's go to network interfaces. Okay, so a lot of stuff right here. Let's go and edit. Change it to. Alright, we have a lot of protocol pre-installed, dual stack lines, and then okay, even link aggregations, PPPoE, switch protocol. I need to fill in my username and passwords for sure. Alright, let's go to the physical settings. I think I need to hit the save button first, and then go to the physical settings. And then I'm going to run my internet connections on VLAN 35. So it is going to be ETH1.35. And then hit save and apply. And on the firewall zone is already in the 1 zone, so it's fine. So we can see that the PPPoE connection come up very fast. We can now delete the 1.6 interface because we terminated it. And yeah, we can see that for this thing, after we press delete, it just deletes and we don't need to do anything. Alright, let me run a quick speed test. Not bad, we are running at 260 or actually 70 megabit per second download and I believe the upload should be 200 Mbps because this is the limit for my internet plan. But anyway, it is doing good. Let's establish the LEDE connection to the router and check it out. By the way, the credential is root and the password is password. So it's OpenWRT 22.07 and this is the LEDE. So if I run HDMI, alright, it has been pre-installed as well. What is happening if I run top? Okay, everything is very standard. Let's see what is the CPU utilization when we are running the speed test. Alright, so it is 78% CPU idle with 380 Mbps download, and it is 91% 90% idle for 220 Mbps upload. Let me check it out if the firewall, if the shortwave offloading is enabled. Let's go to firewalls and okay. So unfortunately, there is no shortwave offloading or hardware offloading option enabled right here, and most likely it is OpenWRT LEDE, not the normal OpenWRT. So this is just my assumption and it may be wrong. So if you have any idea, yes, please share in the comment section. So we have full Connect enabled as well, post forwarding, traffic rules, custom rules. We have a lot of pre-configured rules for AdBlock, OpenVPN, and KMS. Okay, so that is just a short overview of the FastRhino R68s running to OpenWRT, the build from LEDE, and yes, I hope this will be useful for you when you are searching for some information of these routers on the internet. And as I have mentioned, this router is right now still focusing to the China domestic users. So the OpenWRT build is still mainly in Chinese, but we hope that it can go international. Thanks for watching and see you all in the next video. Bye bye.